On May 31, 2013, one tornado accomplished something that experts once believed was nearly impossible. It confused the most experienced meteorologists in America. It trapped thousands of people on crowded highways. And it claimed the lives of 3 of the world's most respected storm researchers. This wasn't simply another tornado. It became the widest tornado ever officially measured, reaching nearly 2.6 miles, 4.2 kilometers across. At certain moments, its winds approached 300 miles per hour, making it one of the most violent atmospheric events ever observed. But what made El Reno truly terrifying wasn't its size. It was the fact that it refused to behave like any tornado scientists thought they understood. This is the story of the day nature ignored every rule. A region already living in fear. 11 days before the El Reno tornado formed, central Oklahoma had already suffered one of its darkest days. On May 20, 2013, a devastating EF5 tornado tore through the city of Moore, destroying neighborhoods, schools, businesses, and leaving dozens of people dead. Television screens were filled with heartbreaking images. Entire streets had disappeared. Families searched through piles of debris for anything that remained of their homes. For many residents, the disaster wasn't just another news story. It became a nightmare they had survived. The emotional scars were still fresh. Every dark cloud suddenly looked dangerous. Every thunderstorm triggered memories of what had happened only days earlier. So when forecasters announced another major severe weather outbreak on May 31st, fear spread across Oklahoma long before the first tornado warning was issued. People weren't waiting to see what would happen. They were already preparing for the worst. The atmosphere begins to change. Throughout the afternoon, warm, humid air from the Gulf of Mexico surged into Oklahoma. At the same time, cooler, drier air pushed in from the west. High above the ground, powerful winds raced across the sky at different speeds and directions. To most people, it looked like an ordinary cloudy afternoon. But to meteorologists, these ingredients were alarming. This combination creates an environment capable of producing rotating supercell thunderstorms, the type of storms responsible for the world's strongest tornadoes. Weather radar soon detected one supercell becoming increasingly organized west of Oklahoma City. Forecasters watched its rotation strengthen minute by minute. Every update raised new concern. This storm wasn't weakening, it was becoming more dangerous. Millions began watching. Local television stations switched to continuous live coverage. Meteorologists interrupted regular programming. Weather maps filled television screens across Oklahoma. People stopped what they were doing. Restaurants turned their televisions toward weather broadcasts. Gas stations became crowded. Phones buzzed with emergency alerts. Families called relatives to check if they were safe. No one wanted another more disaster. The atmosphere inside homes was tense. Children watched adults who suddenly looked worried. Parents quietly gathered flashlights, helmets, and emergency supplies. Outside, traffic slowly became heavier. Many residents believed the safest decision was to leave before the storm reached them. That single choice would soon create a second disaster. A tornado touches down. Shortly after 6 p.m., southwest of Oklahoma City near El Reno, a funnel finally reached the ground. At first, it didn't seem extraordinary. Storm chasers had seen hundreds of tornadoes begin this way. A narrow rotating column stretched from the cloud base toward open farmland. It looked manageable, predictable. Even experienced researchers believed they understood what it would do next. They were wrong. Within minutes, the tornado began expanding. Its circulation widened faster than anyone expected. Fields disappeared beneath swirling clouds of rain and dust. Instead of remaining a compact funnel, the entire storm transformed into an enormous rotating wall stretching across the landscape. Radar operators watched in disbelief. The tornado kept growing and growing, until it reached an astonishing width of nearly 2.6 miles. Nothing like it had ever been officially measured before. The tornado was no longer just growing. It was transforming into something meteorologists had never witnessed before. Its circulation stretched nearly 2.6 miles across the Oklahoma plains, making it the widest tornado ever officially measured. From a distance, the funnel was almost impossible to identify. Instead of a single visible column, the storm appeared as a massive wall of rain, dust, and rotating winds. The danger extended far beyond what anyone could actually see. Storm chasers who believed they were at a safe distance were, in some cases, already inside the tornado's outer circulation. Then the impossible happened. The tornado suddenly changed direction. Most tornadoes follow a fairly predictable path, giving meteorologists and storm chasers enough time to adjust. But El Reno ignored those expectations. It turned east, accelerated, and continued expanding at the same time. Every new radar scan revealed a different story. Forecasters struggled to predict where it would move next. Even experienced storm chasers began questioning what they were seeing. Meanwhile, thousands of residents were trying to escape. The memory of the devastating Reno tornado, which had struck just 11 days earlier, was still fresh. Many families believed getting into their cars was the safest choice. Highways west of Oklahoma City quickly became packed with traffic. Cars stretched for miles. As the storm grew closer, heavy rain reduced visibility to almost nothing. Large hail crashed onto windshields. Emergency alerts sounded across mobile phones. Drivers could no longer tell exactly where the tornado was. Some slowed down, others stopped completely. The roads were becoming a trap. Among those following the storm was veteran tornado researcher Tim Samaras. Unlike many storm chasers, Tim wasn't chasing dramatic footage. His mission was scientific research. Alongside his son, Paul Samaras, and fellow researcher Carl Jung, he spent years developing instruments capable of collecting data from inside tornadoes. Their work had helped scientists better understand some of nature's most violent storms. They had safely documented countless tornadoes before. But El Reno wasn't behaving like any tornado they had ever studied. Rain wrapped around the storm, hiding its true location. The tornado kept changing shape. It kept changing direction. And with every passing minute, the margin for escape became smaller. What had begun as a routine scientific mission was about to become one of the darkest days in storm chasing history.